So there we go. All right, so thanks for the opportunity to speak today. So I am Sarah. I'm a senior lecturer at QUT, and I have a split appointment. So I teach into the Faculty of Engineering this semester. I'm doing process control, which is a fourth year subject. And I also am part of the QUT Academy of Learning and Teaching, which is where I guess a large part of my job is around facilitating professional development in learning and teaching for other academics. So today I'm going to be talking about strategies for developing videos, which is something that I've done over the past 5 years or so as I've moved between various roles. But largely they have been in undergraduate engineering and maths heavy sort of subjects. So I'll talk a bit more detail about where they have been in a moment. So just before we get into that, I wanted to give a little bit of background just in case anyone was a bit unfamiliar with this type of work example type stuff. So I think though pretty much anyone teaching into engineering is going to have worked examples as part of their lectures and their tutorials. And basically what we're doing with these is providing an expert solution to a problem. So this is an example on the right-hand side of what that might look like. This is a problem from dynamics, actually a second year subject, where it's basically asking how quickly is this bar going to rotate as it starts to drop toward the ground. So the worked example is really this solution part, which we can provide here, which works through that problem step by step to find the solution. So we know worked examples are a really key learning tool in many of these maths heavy subjects. That's because it's something that students can sort of look at and sort of try to emulate and understand what's happening within the context of that example. They're really highly structured in terms of that step-by-step sort of systematic approach. And the advantage of that is it reduces the cognitive load on students, which means that they can focus on sort of the important parts of the question or the problem and sort of not get distracted by some of that peripheral information that can appear. So what that means is studies have shown that using worked examples in teaching really is good for accelerating the learning process. Oh, sorry, that was someone with background noise. If you want to put your microphone on mute, if you're not speaking, that would be great. And then, yeah, so once students have engaged with these worked examples, they're able to get those enhanced learning outcomes within the shorter timeframes. So in terms of how we present worked examples, traditionally this has really been through live demonstrations. So in say lectures or tutorial type environments, we work through say on the board or on a piece of paper under a document camera, how we get through a problem step by step. So one of the challenges with that approach is it really has restricted accessibility. Students are only really able to engage with it at that moment if they're present in that classroom environment. And even if they were present in that environment and weren't able to take down all the particular notes that they were engaging with, then it can be a bit of a challenge. So another way that often we present them is through written solution documents. Often this has been done for like homework questions. You know, you set a bunch of problems and you provide people with the worked answers to be able to support them in understanding whether they got the correct answers. So one of the challenges with this is that it's quite poor at communicating the why of why the answer was worked in that certain way. So if we jump back to this particular problem here, you need to sort of have a base level of understanding to be able to engage with, well, what are these diagrams actually showing me? Why are the arrows drawn in particular directions? Why are they applying equations and so on? So unless students have that sort of base level of understanding, worked example in a written form might not be particularly useful for their learning. So another option, and this is the one I'm going to be focusing on today, is around the worked example videos. And these sort of bring together the best of both worlds. They're quite accessible because students can sort of watch them at the time that they want to. And they're able to be narrated, which means that they're able to fill in some of these gaps around the why, those reasoning sort of steps that we take when solving our problems. So this is just an example of one of the worked example videos that I made right back at the beginning for dynamics. It's working through the answer to that problem with the bar falling down the wall. So I'm just going to click play on this. It's a sped up version with no sound, but basically what it's doing is working through step by step where I'm able to discuss, why am I drawing these particular diagrams? What do the arrows mean? Why are they in those different directions? Why am I applying these particular equations? How are we solving them simultaneously? What's the best way to start subbing things into one another, or in this case, solve with the matrix approach? Why can we do that? And at the end, ultimately, we end up with an answer of 3.22 radians per second squared clockwise that it's going to accelerate at. And we're able to sort of interpret that within the context of the question as well. So in terms of what I've done with this sort of worked example video approach, I've created videos for a range of courses since 2016. So it predates the COVID sort of situation. I've mostly done it within engineering units, so mechanics, dynamics, vibration and control. So those are engineering units that sort of run through from all the way from first year up to fourth year subjects. And then as I've moved between other roles within the university, I've been in sort of supporting other units with maths content. So I also became involved in a business statistics first year class, which I put videos into. I taught introductory calculus and algebra for a couple of years, which I popped it into as well, and an engineering computation, which is basically the maths for engineering unit. So basically I've applied this approach to all those different sort of contexts. Typically the videos that I make are between 10 and 15 minutes in length, although there are some that are considerably shorter and some that are considerably longer. I have produced the videos on a Microsoft Surface Pro computer using the pen accessory to be able to do the writing on the screen. But we know that there's sort of equivalent ways of doing that now in terms of other devices. And specifically the software that I have liked for doing this is Screencast-O-Matic. Again, there are other software options for you, but this basically records my voice and my writing at the same time. I have a very conversational style. I'll share the YouTube channel at the end. So if you do want to have a look at some of the videos, you can feel free, but keeping it informal, light, similar to what you would expect in a normal sort of tutoring session is what I've done. And I have used very, very minimal editing to create these videos. So basically whatever is recorded is what you sort of get. And I think that's something that's important to keep in mind, because if you want to try and make something really, really perfect, it's going to take you a very, very long time to sort of get it right. But if you can sort of, I guess, if you're just one-on-one with someone sort of tutoring them, there's going to be little mistakes and things that get made, little slips of the tongue. So I found that, students don't really mind that, and having that sort of minimal editing approach makes it much more efficient to be able to produce this content as well. I've uploaded the videos onto YouTube, and for the initial semesters where I was interested in tracking sort of usage, I did initially have them unlisted. So that meant that the only ways that students could access was through the Blackboard side of the learning management system. But since I have stopped sort of tracking that usage in such detail, they are up on YouTube sort of publicly. The videos were promoted as a supplementary follow-up activity for the most part. So what this meant is that students would attend typically their lecture, they would have a tutorial face-to-face most of the time. And then afterwards, these videos were there to sort of support them as that extra sort of, plugging the gap between there's some problem questions that we've set you, and here's the answers to some extra ones to help you in sort of getting to that point of being able to solve them. So I'm going to focus mostly on these three subjects today, just because they're the ones where I've done the bulk of the research around tracking the engagement, as well as surveying students about their engagement as well. So the subjects are mechanics, which is a big first year core subject for all engineers, dynamics, which is a second year subject for mechanical engineering students, and control systems or vibration and control, which is a fourth year or third or fourth year subject for mechanical engineering students as well. So these subjects are relatively big, especially the mechanics one, since it's core. And it's been run over, initially the starter collection was 4 semesters that I did it for. However, basically these videos get recycled semester to semester in exactly the same form. So they've been used all the way from 2016 up until they're still in use today in these subjects. In terms of the total numbers of videos, mechanics, I think, had the most, just because those ones were much quicker to do. Worked examples are quite simple, I would say, to be able to get through, whereas these other subjects, they tend to be much more involved. So I didn't record quite as many. I also put a sample exam solution into mechanics, which is 20 of these videos as well. In terms of views, you can see that there was thousands and thousands of views through this period. Watch time was pretty big as well. I popped in some averages. I think the biggest usage really sort of came through that mechanics cohort though. And I'm going to talk as well about the survey that I did. So the response rate to that was about 20% across the units. So some of the early findings that I had in terms of the usage was that really it was strongly correlated with assessment. So what that means is that if there is a problem solving task or an online quiz, something like that, in the days leading up to the due date, that's when the hits on the videos really come to light. So I think you can see that with the black line here. I think there was a problem solving task due around this date here. It drops down and then rises up for a second problem solving task. And then you can see at the end, this like sort of goes off the chart. This is the exam block sort of spike. Same with the red line, that's mechanics. I think there's a submission point here and here where you can see, yeah, there's that elevated usage through that time. So I think probably the biggest finding from this for me was around really exam block is the bulk of sort of that where that motivation comes from for students wanting to revise, all the content that they've covered across the semester. And that's where these videos really see that really increased heavy engagement. And that I should mention as well is why I decided to put sort of a sample exam set of questions with video answers into a couple of subjects for this very reason. So another key early finding from me surveying students was around how they were engaging with the videos. So often people will talk about videos as being a really passive medium, something that students are just, watching and not really engaging with in too much depth. However, what I found was that students really were engaging actively with these video resources. So what we can see here is I asked students how they typically interacted with the questions that were presented in the worked example videos. And overwhelmingly, students were attempting those questions. So sometimes they would do it after watching the video, sometimes they would do it before it and then check that they got the answer correct. Other times, and this I think was definitely the most popular answer, was to attempt while watching. So this would mean students would pause the video, have a go themselves, and then start the video back to double check that they got it right, or to get some guidance if they weren't quite sure, what they were supposed to be doing next. This came out a lot as well when I asked students to sort of comment on how they did it in their own words. So these are just typical comments that came back time and time again. So I paused throughout the video, attempted to move further from there. And if I was stuck, I would continue with the video. Other students saying I usually skipped over easy bits, repeated watching those parts that were important and challenging. So yeah, the very, very strong themes that came out was around this sort of active engagement with those videos. Another key early finding that came out was that students really perceived that these videos were helping them understand what was happening in terms of the engineering and mathematical concepts. And they perceived that this would convert or translate to them getting a better grade within their unit. So that's what these are showing here. They were Likert scale questions. This one is my understanding of the unit improved after using the videos, and we can see that very overwhelmingly for strongly agreement on that item. And same for this one. I think I'll get a better grade in the unit from using the videos. Overwhelmingly, students do agree with those statements. In terms of sort of testing this more empirically has been a challenge just because of changes in terms of cohorts, assessments changing over years and things like that. So I haven't been able to sort of do a definitive, control and treatment study to look at the change when these videos were introduced. However, there are plenty of other studies out there which have been able to do that sort of more controlled control and treatment study. And they have shown that this type of video resource is able to deliver those benefits in terms of learning outcomes. So another one is around students believing that, they were better satisfied with the units that they were studying. So in terms of mechanics, the grey lines here are before videos were introduced, and the red lines are the 4 semesters after they were. Similar for these, grey lines are the before, blue and black are the after. So in each of these cases, there has been a bit of a jump in terms of that overall, I am satisfied with this course answer. So again, students are, I guess, happier in terms of working through these units when they've had these supplementary videos to work with. All right, so I basically did that research which looked at, how students were engaging with those videos. And one of the questions I sort of came to was, okay, so why are these videos actually so effective? what are some of the strategies that I'm using that potentially could be like bottled up and, implemented, as something to be focused on for other people that might be trying to produce this type of content. So I came across this model a few years ago called the technology acceptance model. It's quite popular in terms of technology adoption, but basically what this model says that there is two key things that impact whether students are going to use a piece of technology. One is the perceived ease of use, how easy is it? And the other one is how useful that particular thing is. And there are some external variables that basically determine whether they think it's easy to use or useful. And this all the way translate down to actual usage in the end. So what I sought to do was apply this to the worked example video concept and come up with what those external variables were that were influencing students to ultimately choose to use the videos in the end. So this was done through thematic analysis of student responses to the survey that I had conducted over a number of years. So I came up with sort of 7 key ingredients that sort of contributed into this. So in terms of things influencing the ease of use of these resources, accessibility, the personal agency students had, findability of content, and the instructional design and production strategies were the key things. And in terms of them, what made them useful, the explanations and the narration that was in the videos, scaffolding of content was also deemed to be quite useful, and the alignment of the videos within the overall course. So I'm going to go into each of these in a little bit more detail on the next slides. So in terms of accessibility, I think this is probably the dominant theme that came out of the thematic analysis for ease of use. So students really liked the fact that they could watch those videos at any time, at any place. They could go back and review them as well as many times as they wanted. And as we saw from the usage graphs, it's very clear that students are using them toward the end of semester when they're reviewing for exams. So that was definitely a key reason for students thinking it was quite easy to use. The distribution platform did appear to play a bit of a role in students thinking the videos were easy to use. So I often got comments about YouTube being a really good platform for this because I guess students are quite familiar with it in terms of using it in their everyday lives already. And YouTube is quite user-friendly across a range of devices as well. You can sort of just jump on it on your phone, you can watch it on the computer, you get a quite nice viewing experience no matter what. And it also adjusts, I guess, to your internet speed. So if you have quite poor internet, YouTube will automatically sort of drop you down to be able to accommodate that. Often students would comment on the or make comparisons to the institutional's sort of lecture platform, which is Echo 360, and how YouTube was much more user-friendly than that. And that came out quite strongly in the results. The last one around awareness here, there was comments that came back around students not being aware that the videos existed until the very end of semester. And this was despite, repeated, I guess, communication throughout the unit that, these videos do exist as a support mechanism, but students just not being, particularly across that for whatever reason. So I think an important thing to think about here is if you're going to implement sort of these supplementary type videos is to make sure that you've got a communication strategy around that to ensure students are, across that they do exist and the benefits of using them. The next one was around personal agency. So here students really talked about how it was beneficial to be able to use these videos at their own pace. They could pause the video, have a go at it and take as long as they need in that moment to have their go, and then go back and watch the video, start it again, to be able to clarify their understanding and things like that. So that self-pacing, definitely came out as something that students really valued. Being aligned to their needs was another thing. So often students would talk about, I only picked out the videos that in the topic that I was struggling with and sort of focusing on that area of need. Students would also talk about sort of skipping the easy examples and sometimes just wanting the more difficult ones. And that was actually something that was quite unexpected to me. I would have students asking me for more difficult questions if I could record those as a bit of an extension activity. So I think, again, that video medium is really good for being able to target students who potentially, maybe don't have the prerequisite knowledge, but also students who want the extension because they're able to pick and choose which content that they actually watch. The next one around findability. So students would talk about how it was really easy to locate the content that they wanted. This was because the videos were well labeled. You know, each week would have its own folder with the video sitting underneath it. They would have titles that were fairly descriptive. So those were really good things for being able to identify what they were looking for if they were seeking help in a particular concept. And students would also talk about the videos being easy to navigate, as opposed to, say, a 2-hour lecture where the you know, examples might be interspersed, you know, all across, and it's hard to find exactly what you're looking for. These were concise, you know, there was one problem to a video. They would basically follow the same structure each time, where start with what the question is, how you're going to approach it, work it through step by step, and in the end have a final answer. So yeah, having that consistent approach came off well. The last one around instructional design and production attributes. So students liked that the videos were bite-sized and sort of held to that structure that I just mentioned. As well, students liked that they were quite conversational and personal, sort of like you were just having a conversation with them about how to approach these topics. I think another thing to maybe highlight here is that students didn't seem to mind that the videos were quite simplistic in them. I showed you that example where it was basically just me sketching handwriting on a screen and drawing dodgy, you know, pictures and things like that. Students were quite okay with that really simplistic design. So in terms then of usefulness, so the 3 things here, the first one was around explanations for understanding and how that made the videos really useful. And again, within this usefulness theme, I think that was the dominant part that came out. So students really appreciated when stuff was communicated really explicitly in terms of that thinking process and filling in the why or the rationale for approaching a question in a particular way. Students also liked it if you talked about multiple approaches to the final answer. And I thought this was quite interesting as well, because students didn't seem to mind even if the videos were a bit longer and sort of, you know, covered those extra sort of, I guess, avenues for exploring how that problem might be solved. Context scaffolding. So here it was really around making sure that the videos had a range of difficulties and ensuring that they built upon one another. So I would usually have a recap video at the beginning of each topic, which provided just the equations that were needed or any other sort of theories that were needed for that sort of topic area. And then I'd start in the folder with the simplest example and build up to ones that were more and more difficult. So that structure was viewed quite well. And the final one here is around course alignment. So students really valued when the assessment aligned to what was in the videos. I think if there wasn't that alignment, you wouldn't have seen those spikes around the assessment sort of due dates. So I think for students, the value proposition really comes from that, you know, an alignment between the learning activities and resources that we're providing and the assessment, and being able to, you know, support them in bridging the gap themselves to be able to apply those concepts and things onto the assessment items. So that alignment was really important for students to see the videos as being useful. All right, so I think this is my final slide around some key recommendations that have sort of come out of my experience and my research around this video approach. So the first one I've got is around extended capabilities of the distribution platforms. So I think things have come quite a bit since I originally started doing this in 2016. But thinking about how you can make use of things like playlists, subscriptions if possible, such as students being able to be alerted when there's new content, and the commenting. So this is where students are able to sort of ask a question and get a response back. So for example, at 10:26 in the video, you did this, can you clarify why this worked? And I found as well, students will reply back to one another on those chains as well and pick you up when you make silly little errors that you didn't quite see the first time. Implementing a communication strategy. So this really goes back to that challenge I had around awareness of the videos. And I think since students really value the connection to or alignment with assessment, I think selling the videos with that connection is a way of sort of getting them to realize earlier in the semester that these resources exist. And they're quite useful for their learning. Developing content at a range of levels is another thing I'd recommend, just because we know that often, at least at QUT, we end up with students who are at a very, very wide range of levels, especially in those first year units coming in. So there's a lot of bridging that needs to happen for students who lack that prerequisite knowledge. But then we also end up with high achieving students who want to be extended. So I think this video approach is something that can be really good for catering to these different cohorts. Including alternative solution approaches within your videos is something else that you can consider. And as well, thinking about how you can communicate those solutions. So, for example, students sometimes would attempt the problems and then, basically pause the video at the beginning, work it through, and then jump all the way to the end to double check that they got the final answer. So students are employing that sort of approach in their feedback to me would sometimes say it would be nice to just, have the answer sort of written there without me having to go through the entire video to try and find where that appeared. So what I would usually do is highlight the answer at the end so it became obvious that that was it and people could sort of jump to it. But thinking about as well, maybe students can also just work with the sort of written answer if they've got that sort of depth of understanding to know what's going on. So yeah, students, I guess we're asking for different ways of being able to view that content according to what level of learning they were within the semester. Educators should focus on the clear communication of the solution approaches, including alternative methods. And I think the caveat here is even if the videos increase in length, students are still going to value it. If they want to watch it, they will. So thinking about how you can explicitly communicate the strategies that you're using is really, really important. If students aren't interested or they've already grasped that, they're able to skip ahead. So students are able to self-pace and self-identify what they want. So as long as you're providing that content, it's up to them to engage with it or not. And the last thing I've got there is around investing time in producing simple educator-made content. This is because students perceive it as quality assured when it comes from their own teaching team and quite personal in nature, as opposed to going out and looking on YouTube more generally for generic sort of content, where sometimes the approaches they apply or the variables they're using in terms of notation differ or the units differ. If you're producing this content within your own unit, I think it's got that connection back to everything else that's sort of going on, which students really appreciate. And I'd also like to emphasize the simple here. They don't need to be overly fancy in terms of these videos. Students will value them, as long as they're, producing or providing them with what they need. They see them as useful. They don't need to be fancy, all out productions. So in terms then of follow-up, I've just popped in here, I'll pop it in the chat. There's my email address and also on a website, you will be able to access the research publications if you're interested in looking at that in more depth, as well as the YouTube channel that I have, which has all the videos up there that you're able to have a look at in more detail to see what I've done. So I think I'll leave it there, which is the half an hour that I was told to try and aim for. And if there's any questions, I'm more than happy to answer now.
Thanks, Sarah, for this very interesting presentation. If anybody has question, maybe you can write it down in the chat and then we'll just go through each of the questions. Sarah, do you have a personal YouTube channel? It says Sarah Dart, me. That's your website.
Yes, yeah. If you go to that, there's a link
on YouTube.
Yeah.
Okay. Anybody would like to ask any questions? We have 2 papers published based on your research, right? I saw that it was on the back.
Yes, there's 2 journal papers and there's also a couple of conference papers that I've done. And I have a 3rd paper, which has been accepted, but is still in the final stages of production, which is looking at the stuff in the business unit that I mentioned at the start. So, yeah.
Well, I see in chat, everybody says, fantastic job, Sarah. Thanks, Sarah. Thanks, Sarah. I was just wondering, did you do any investigation on how these videos would improve the marks of students? Was there anything like that you have done in the past several years, when you have used all your videos? Because you have used it for many years, right? And you have hundreds of videos. So did you do any research on how these videos will maybe improve the marks, or I don't know, like final mark or things like that?
Yeah, so the main thing for the engineering units is I asked students of improvement. This was because initially I didn't really plan to do this as a control and treatment study. So unfortunately, there was big changes in terms of assessments. There was cohort changes, course changes, things like that. So unfortunately, I'm not able to do a definitive control and treatment in this. However, for the business statistics unit, that one was a bit easier to have a comparison, because that unit stayed very much the same in the 2 years before I introduced videos compared to the 1 year. So in terms of that one, there was a statistically significant improvement in the semester 1 and semester 2 cohorts for that unit. However, there's also a summer semester cohort that didn't really see any improvement. There was no significant change in that one. So yeah, I think there is evidence of it improving things, and other people, as I said, have done studies which have looked at this, with those control and treatment studies, and have found improvements. So yeah, just hard to measure, I think.
Thanks. Thanks, Sarah. There's a question. Have you ever considered using a glass board for writing analog instead of digital? I think it's kind of technical question.
Yeah, so I have not tried to use one of the light boards. I think QT has one now, but I have not used it. Originally, when I did these, I basically got that Surface computer and decided this was a cool thing I could do, and I found it quite easy to sort of do those. I think the advantage of doing it via the Surface sort of approach is that my face isn't in it, and I think a lot easier to sort of do it, as well. If I make a mistake when I'm doing those videos, I can sort of just pause it and jump back, to where, 30 seconds beforehand, and start recording again. And you can't see any sort of change, I guess, in terms of the progression. It's just as if it continued. Whereas I think if you use the glassboard approach, since your face is in it, I feel like you'd see those jumps if you did want to do any editing to cut it out. So yeah, but I think it's definitely a valid way, and there is research that says that including the instructor's face can make videos more engaging as well. So definitely something to consider. Did you have a question? Your name is put in as STRUC.
Yeah, I do.
Yes.
Yeah, my question is, you're looking at alternative methods for solving problems. But I guess there are alternative numerical or analytical ways of dealing with them. Have you considered using experimental evidence to back up the results? And if you have, and if you haven't, why not? Because they do exist.
Yeah, so often it would be, you have your maths problem and there's multiple ways to get to that final answer. So that's what I mean by the alternative methods and demonstrating those different ways that sort of get there. But in terms of what you're saying, so I did do this sort of for control systems. That one is a subject that includes quite a bit of like work the problem by hand, and you've got sort of these simplifying assumptions, and then you can do it on MATLAB and sort of simulate it and see what those differences are. So that actually went down quite well in those sort of subjects, demonstrating the two different methods. And then if you do have differences across them, talking about how the assumptions sort of are impacting, what you're seeing.
Yeah, I'm a very devout experimentalist. And one of the things that I've learnt through years of teaching mechanics and dynamics is hands-on learning. Is an important part of understanding what's going on, synthesizing a problem, and then using the appropriate tools to analyze and get the answers. And so I've worked very hard personally to produce material that is experiment-based, and in two levels. Hardware, very small experiment frames that can be used, students working in pairs or on their own in solving mechanics problems, dealing with mechanics problems, simple beams, for example, trusses, dynamics, vibrations of two-story buildings, sway frames and so forth. But these are hands-on and investigated experimentally. I've also gone to the trouble of creating videos now of these experiments with particular focus topics for kids to learn from. I call them kids because they're way much younger than I am. I'm over 70. And these videos are available to universities if they want to subscribe to them and include them in their online delivery to enhance the teaching of basic material in engineering, mechanics, statics, dynamics.
Sounds good. Yeah, I guess.
And it is available. All I'm saying is it can be enhanced. Whatever you do can be enhanced by having experimental-based evidence of the answer even. But it's not just about getting the answers, it's understanding how to get to those answers. And that's what I like about the way you treat your videos, that there's an explanation as to why you use the arrow this way, as to why you took the free body diagram the way you did and interpreted it. But boy, that dynamics problem that you showed, if you had an experiment of a roller with a roller base with a leaning ladder, if that's what it was, and you just let it go, you videoed it, yes, and then you scanned the time history of movement of the center of gravity or whatever point you want using software that is readily available, tracker. You can also show what the initial acceleration value would be from that experiment.
It's like triangulating with another point of evidence as well. So yeah, no, I like it.
The difference is it's experimental. It's sort of the real thing as opposed to another method of analysis. Even with the other technique that you talked about, or sorry, the other subject that you talked about, you went to MATLAB. Well, MATLAB uses the same theory and uses the same sort of stuff, but it's sort of packaged in a different way. And yes, it verifies your answer. To me, that's less convincing than seeing an experiment rather than seeing another method that uses the same modeling technique to come up with the answers.
Yep.
Anyway, that's just something I'm throwing in. I'm not trying to belittle what you're doing. I think it's great. It's really great, but I think it also can be enhanced through some experimentation. For a student who's looking at something for the first time, I think they would learn a lot better and understand a lot better that it's not just about getting the answers, it's about understanding how we are modeling things and why it works.
Yeah, I think that's one of the challenges in mechanics in particular, where they're sort of first grappling with the free body diagrams. I think making the connection between, real life, what does a pin look like in real life? And then how does that translate to this little symbol that we're seeing? And, why are we drawing the forces in this particular way on this symbol compared to others? I think that is a big sort of threshold to pass through. So, yeah.
I can very much sympathize with you.
Yeah.
Because I've been running courses in mechanics and statics and dynamics for well over 40 years. And I've seen lots and lots of students struggle with these concepts. And it's that light bulb moment that you look for, or at least I do. And all of a sudden, a student says, I now understand shear force and bending moment. Gee, I've been grappling with that first year, second year, third year, and finally in design, if that sometimes happens, I finally understand what it means. Wouldn't it be nice if that was understood earlier?
Absolutely.
And
yeah.
that's why I'm concentrating on experimental-based evidence, because they see it and understand a little bit better when they're close up to it and doing it hands-on for themselves and verifying these things on a simple experiment. Anyway, I'm just chucking that in.
All good. Are there any questions?
Any more questions? Very good discussion. Anybody would like to comment? Yeah, Richard. Yeah, you want to speak or you want to type? Okay, just like speak then. Yeah.
No, great presentation. Nick and I were joking a little bit before because I grew up with a Sarah Dart, and I was like, oh, I wonder if it's no, but you're not. I'm
Really?
sorry. We don't know each other. No, great presentation. I agree with Nick as well. There's a lot of work that you've done there, and that graph that you had before to show like the workflow of how to measure. I'm not sure which slide it was, sorry, but to get to measure the differences between what the student outcomes were, basically, I think is a really good metric for, it's essentially a metric for success ultimately. And as someone who used to manage Echo 360 systems, and that was my job many years ago for managing collaboration technologies for the universities, for multiple universities across the country, one of the key things was always, is it easy to use? I know that universities have, their priorities as far as, managing and controlling intellectual property, and there's things that Echo 360 can do that YouTube can't. But at the end of the day, if the basic experience of watching the video isn't good, that's what the reality is. So anything that gets in the way of that experience is not a good thing. So a platform is one thing, but the way that the content is brought across and the way that it's embedded in helping a person. I think you wrote at one point, grasp is a really good word of like, because when you grasp something, it's not just, like Nick was alluding to there with, you're not just getting the result, you're getting everything leading up to that result, which is usually a lot more important than just the result. So, and especially someone like Nick, who has been doing this longer than I'm alive, can rely on his experience to know what the result will be. Whereas if you have a student that's just learning, they have to do so much more work because obviously they haven't been doing it for 40+ years, for example. So anything that helps somebody grasp all the way up to having an understanding is a really, really important thing, and will create the next generation of engineers. So awesome work. And I forgot what my question was.
I thought you were going to ask me about YouTube and whether that was good. QUT have just rolled out a new video platform this semester that I think it's Kaltura. It seems to like do a bit more of what YouTube does compared to what we had in terms of Echo 360. Although I think Echo 360 has come a little bit in terms of what its capabilities are from 5 years ago as well. So yeah. Keep in mind.
We have a question from Ruan, right? Ruan, you raise your hand?
Hi, hello, my hand. Thanks again for the video. I've actually been recording my videos with Teams because I found that the subtitling was very easy to edit, and we have some deaf, like students with hearing issues. So, but one of the things I wanted to ask was, do you ever wonder whether there's like a danger to, that what you described, your ability to fast forward to the end and get these quick answers? Because what I've been seeing is that my students are incredibly good at following kind of like procedural knowledge and kind of repeating a set of actions way better than in a way staff are when it, especially with computing. But where it gets difficult is the moment interpretation is needed. And I just wonder whether with all the kind of like quick learning methods that detracts from like deep learning.
Yeah, I think it's a good question that you ask. I think a lot of students are motivated by what assessment requires them to do. So if assessment is only asking them to basically regurgitate a process back, then I think that's what students will focus on. Whereas I think if, the assessment is gearing them toward more of those higher order thinking, interpretation areas, then I think students are sort of motivated to engage with that more. Personally, I don't think it's a problem if students want to start the video, have a go at it themselves, and then skip to the end to check they've got the final answer. Because, the students that are doing that, I think for the most part are the people that have the, that level of understanding to be able to know, okay, if I did get the right answer, that means that I, applied the right steps and things like that. Whereas if they, don't get the right answer, that's when they go back and start to, watch the video and be able to engage with that reasoning side of things and try to grapple with, where did I go wrong? So yeah, does that answer your question?
Yeah, to a large extent. I mean, see, I actually teach architecture, not engineering. And so part of the hand-in is usually that you have to design something completely novel that, you know, nobody saw before. So we completely kind of move away from, you know, formulaic results. And I've, to a large extent, struggled with online teaching because so much of what we do on my side is much more about, you know, conversations and kind of prodding, sometimes prodding with a cattle prod. So yeah, it does not lend itself as well to, you know, I guess a procedure. But I think you also mentioned that about 20% replied to these surveys. Sometimes I feel like maybe if it is people that are in the top 20, they would be, this kind of ties back to the question I think that was asked before about is there an improvement in grade? I kind of get the feeling that maybe those that are like really diligent students would do well regardless of medium, and maybe the real benefit of online learning is that it kind of can help those that you know, are probably more struggling.
Yeah, so I think from the results I got out, it really felt like there was different cohorts within it. You know, students would talk about how they were students that would struggle and, you know, didn't have that prerequisite knowledge and really felt like they benefited from being able to sit down with these videos and be able to engage with it at their own pace and catch up on things that maybe, you know, were passed over really quickly in the face-to-face classes. But then, as I said before, what's really surprised me was that there was also the high-end students asking for extension through this medium as well. So I think, yeah, I mean, I know it's only a 20% response rate and that is a limitation, but I think within that, you know, there was still representation from people that were sitting within those different cohorts, cohorts within the cohort as well.
Well, I should also just quickly add, I'm from QUT as well. I just left in 2013.
Oh, same school. Sarah, can I just ask you a question, kind of quick question? Do you actually ask them to watch those videos before lecture, like sort of like flipped class, or do they actually like watch it after lecture, like after like your tutorial, so that they can also maybe
yeah, so
catch up with like what they missed? Or...
Yeah, so these videos were presented as supplementary material.
A supplementary material.
And their lecture and tutorial ideally. And then afterwards, I guess there were still like problems, follow-up problems that they could attempt. And this sort of supplement as well as an additional sort of avenue for them to be able to engage with these problems outside of class. So everything that students engaged with was entirely voluntary. And yeah, we still saw, even with that, massive engagement numbers.
I see. I have something similar also, videos and also labs for like hands-on practical experience. And I'm thinking about about doing something like a flipped class and ask them watch like those videos before the class, but I'm not sure if they will. They may probably like have no time, or maybe they're not really interested, so they'll wait until the lecture. Maybe after that, if there is any assessment item, they'll probably like watch like those videos as additional resources, like learning teaching resources. Yeah. But would be like really great if they could actually watch it before lecture, so that they would be prepared for lecture and that they would know this material, or at least have some idea. So I just don't know how to like make them watch it like before the
I think you picked up on one of the big challenges of the flipped classroom approach, is that if most you've got a highly motivated cohort,
yeah, that's true, but
in many cases they're not going to watch these resources beforehand, in which case you're sort of back to square one, or trying to cater to a cohort who has actually prepared and a cohort who hasn't actually prepared. So yeah, that's why I quite like this approach, this supplementary approach. It also means that like people, because I've done this as like a tutor and also sort of a support person within units, and it means that I can sort of come in and provide this as an additional you know, resource, and they don't have to adjust too much what they're already doing within their lectures or tutorials or other learning activities which happen in the unit. This can sort of just act as that extra, you know, buffer for students who want that extra support, which has been quite good. You know, as I said, not being the person that's in control of that unit, but being the support person within it.
Yeah, thanks, Sarah. Any more questions? Anybody would like to ask more questions? Can I just ask maybe like final question?
Yeah.
Do you share these videos with other units, with other schools, or it's only for like your school QT, or because we also have like math classes at Griffith, and that actually would be nice maybe if we can like maybe you can share it with like our students, so that
I would be more than happy for, yes, I'd be more than happy for people to reach out and
okay. Okay, great. Okay, if no more questions, I would like to thank Sarah for very interesting presentation, for your time, for these insights and videos. Looks like many people have done something similar, or maybe thinking about doing like something similar. So, well, thanks for your time, and thanks for a very interesting presentation.
Thank you. And yeah, please get in touch if you do have any other questions and things like that.
Yes, we will. Yeah.
Cool.
Okay, great. And I think we finish on time, just right on time before 1 p.m. Okay, thanks everybody for joining the session. We have it every month, so we have something next month as well. Have a nice day, have a nice Friday and weekend. Don't drink too much here. Bye, everybody.
See you later.
Yeah.
See ya.